2.6 kilometers. That's the diameter. Measured, confirmed, post-perihelion Hubble data, November 2025 through January 2026. Not a guess, not a projection, a number pulled from stacked imagery after months of observation. 1.3 kilometers radius, plus or minus 0.2. Now hold that number, because what it reveals is not just the size of one interstellar object, it reveals how blind we've been. For decades, maybe centuries, objects like 3I Atlas have been threading through our solar system, and we never saw a single one. Let's put this hull in perspective. The first interstellar object we ever detected, Oumuamua, was less than 0.2 kilometers long, a sliver, a fragment, thin as a blade. The second, 2I Borisov, measured 0.7 kilometers. 3I Atlas dwarfs them both, 40 times more massive than Borisov, at least 20,000 times more massive than Oumuamua. 20,000. Some early estimates placed it at 50 kilometers across. That would have been a sentinel the size of a city. The real number, 2.6 kilometers, is smaller. But don't let that comfort you. A 2.6 kilometer nucleus is enormous by interstellar standards. It places 3I Atlas in the range of a solar system comet, a planetesimal, a body with the mass of a mountain, ejected from a distant star system and hurled into ours at 60 kilometers per second. The fastest object ever observed in our solar system, not orbiting, not returning, passing through, on a hyperbolic trajectory that bends once around the sun and then never comes back. Now here's where it gets cold. Researchers took the size estimate. They took the albedo, 0.04, a standard assumption for dark, ancient surfaces. They took the detection history, Oumuamua in 2017, Borisov in 2019, 3I Atlas in 2025, 3 interstellar objects in 8 years. And they ran the probability, the result. At any given moment, there should be at least one interstellar object within 4.5 astronomical units of the Sun. 4.5 astronomical units. That's inside the orbit of Jupiter. One object per year, passing through the inner solar system. Every single year. Let that land. We have had wide-field CCD surveys, scanning the sky for far longer than 8 years. We've had observatories, automated trackers, all-sky monitoring systems, cataloging every point of light that moves. And we found three objects, in a zone where the math says there should be one every year. Where are the rest? We missed them, not because the telescopes malfunctioned, not because the sky was cloudy, not because the data was corrupted, because we weren't looking for them. We didn't believe they were there. The paradigm said interstellar visitors were theoretical, exotic, once-in-a-lifetime events. The paradigm was wrong. The instruments were ready. The minds were not. And that is the most dangerous kind of blindness. Not a failure of technology, a failure of imagination. Now expand the frame. 4.5 astronomical units is the inner zone, Jupiter's orbit. Neptune sits at 30 astronomical units. The volume of space between Jupiter and Neptune is incomprehensibly larger. And beyond Neptune, the Kuiper belt. 50 astronomical units, maybe more. If one interstellar object passes through the inner solar system every year, how many are drifting through the full volume right now? Not one, not 5, dozens, maybe hundreds, some active, in outgassing, shedding dust and molecules as they warm near a star, others cold, dark, silent, invisible to our surveys. A 2.6-kilometer body with an albedo of 0.04 at Kuiper belt distances would be a ghost, undetectable with current technology. And they're not confined to the ecliptic plane, the flat disk where the planets orbit. They come from every direction, above, below, behind. Objects like Comet Bernardinelli-Bernstein, UN 271, was found far below the inner solar system, completely off the expected plane. The void is not flat. It is three-dimensional, and it is full. TESS, the Transiting Exoplanet Survey satellite, captured 3 I-Atlas on camera between January 15th and 18th, 2026. Stacked imagery, composite video. The object held fixed in frame while the background stars streamed past, moving, fast, relentless. No sunward-facing tail in this data. Instead, an anti-velocity vector tail. Dust and grains pushed backward, opposite to the direction of travel, not dragging behind like a comet's tail blown by solar wind, pushing out, against its own momentum. The latest data also confirms an asymmetry. Before perihelion, October 29, 2025, 3I Atlas was brightening, active, building energy as it approached the sun. After perihelion, it faded, fast, faster than models predicted. The outbound light curve does not mirror the inbound one. Something was released at perihelion, something that was stored inside, sealed beneath the surface, and is now depleted. The brightness dropped. The chemistry shifted. The methane appeared only after the closest solar approach. This is not a snowball melting symmetrically in the sun. This is a body that activated, discharged, and went quiet. Think about what this means for history. Before 2017, we had never confirmed a single interstellar object. Not one. In all of recorded astronomy. Then, 3 in 8 years. Oumuamua, Borisov, 3I Atlas. Each one stranger than the last, each one larger, each one more chemically complex. And the math now tells us they've been coming through all along. 1 per year, minimum. Through the inner solar system alone. That means during the Apollo missions, interstellar objects were here. During the launch of Voyager, they were here. During the construction of Hubble, the mapping of the cosmic microwave background, the discovery of dark energy, they were here, passing through, unseen, untracked, unacknowledged. Objects from other star systems, carrying unknown chemistry, an unknown structure, unknown history, slipping through our solar system, like ghosts through a locked house. And not small ghosts, bodies, kilometers across, mountains of ice and rock and organic molecules from alien suns. We built our entire model of the cosmos without accounting for them. Every textbook, every simulation, every projection of what our solar system contains, incomplete. And now we know they've been part of the equation the entire time. Invisible variables in every model we ever trusted. 3I Atlas is currently between the orbits of Mars and Jupiter, approaching its closest pass to Jupiter on March 17th. After that, it's gone, out through the asteroid belt, past Neptune, into the interstellar void. It will not return. And when it leaves, it takes its data with it, its methane, its anomalous chemistry, its 2.6-kilometer nucleus that defied early predictions. We will have images, spectra, light curves, numbers on a screen, but we will not have the object. And the next one is already on its way. The surveys are improving. The Vera Rubin Observatory is coming online. Future all-sky systems will scan deeper, faster, wider. We will find more interstellar objects. That is now a certainty. The question is not whether we'll find them. The question is what we'll do when we realize how many have already passed through, undetected, carrying chemistries we never analyzed, structures we never imaged, and origins we will never trace. The void does not announce its visitors. It does not send warnings. It sends objects, massive, fast, chemically loaded, through the heart of our solar system, and it dares us to notice. For decades, we didn't. 3I Atlas changed that. Not because it was the first, but because it was the first we couldn't ignore. 2.6 kilometers of interstellar mass, 20,000 times heavier than Oumuamua. Methane that appeared on a delay. A brightness curve that broke symmetry at perihelion. A tail that points against its own velocity. And the statistical certainty that dozens more are out there right now. In the dark. Between the orbits. Above and below the plane. Surrounding us. We didn't discover interstellar objects in 2017. We discovered our ignorance. For thousands of years, we mapped the stars, named the planets, charted the comets, and we assumed that everything passing through our sky belonged to our sun. It didn't. The void has been sending messengers, and we've been calling them noise. If that thought stays with you, if you feel the weight of what was always there but never seen, then you understand why this matters. Stay vigilant. Subscribe, because the next flyby won't wait for us to be ready. And the void keeps sending. In Cosmos, we trust.